All right, let's dive right into it. Our topic today is quite fascinating. We're going to explore the world of ornithopters. Now, that's a big word, isn't it? But don't worry, it's not as complicated as it sounds. Essentially, ornithopters are aircraft that imitate the flight patterns of birds. Yes, you heard that right. Um, we humans have always been fascinated by birds and their ability to fly. And we've created these incredible machines that attempt to mimic them. So, how do ornithopters work? Well, well, it's all about a flapping motion. Unlike airplanes or helicopters, which use static wings or rotating blades to generate lift, ornithopters use a flapping mechanism to fly. This flapping motion is vital. Each flap of the wings of an ornithopter performs two functions, thrust and lift. When the wings go down, they push the air downwards, which generates an upward force or lift. Simultaneously, the downward motion also propels the ornithopter forward, creating thrust. When the wings move up, they're angled in such a way that they slice through the air with minimal resistance. Well, this is quite similar to the way birds fly, right? But it's not just about flapping up and down. The wings of an ornithopter also twist during each flap, just like a bird's wings. This is referred to as active twisting. The combination of flapping and twisting allows for better control and efficiency. So in essence, ornithopters are a fascinating blend of biology and engineering, bringing together the natural world and human ingenuity in a truly unique way. But remember, as simple as we've made it sound, achieving this flapping motion in a mechanical device is no easy task. The forces at work, the materials used, the design of the wings, all these factors play a crucial role in the successful operation of an ornithopter. But we'll get into those challenges a bit later. For now, let's appreciate the beauty and complexity of these amazing machines. The way they emulate the graceful and efficient flight of birds is truly a testament to the wonders of engineering and the endless inspiration we draw from nature. So that's a basic understanding of how ornithopters work. Up next, we are going to delve into the history and evolution of these fascinating machines. Stay tuned. All right, now that we've grasped the basic principles and mechanics behind ornithopters, let's take a trip back in time to understand their history and evolution. The idea of creating machines that fly by flapping their wings is not a new concept. In fact, it's as ancient as human fascination with flight itself. The term ornithopter originates from the Greek words ornithos, meaning bird, and pteron, meaning wing. Humans have been fascinated by bird flight for centuries, and this fascination has led to various attempts at creating flapping wing aircraft. The earliest known attempt dates back to the ancient Greek engineer Archytas of Tarentum, who reportedly designed a bird-shaped machine that was propelled by steam. Fast forward to the 15th century, and we have the legendary Leonardo da Vinci, who made numerous sketches of ornithopters in his notebooks. Although his designs were never built, they showcased an incredible understanding of the complexities of bird flight. In the 19th century, an Englishman named George Cayley built small, hand-launched ornithopters, but it wasn't until the 20th century that the first manned ornithopter flight took place. In 1942, Adalbert Schmidt flew an ornithopter with a wingspan of 32 feet for a distance of 900 meters. This was a milestone in the history of ornithopters. Since then, the designs and technology of ornithopters have seen significant advancements. Modern ornithopters have utilized materials like carbon fiber composites and lightweight alloys to make the structure stronger yet lighter. They've incorporated variable wing geometry and even computer-aided control systems to improve stability and control. Today, we have ornithopters of all sizes, from large manned vehicles to tiny insect-sized machines. Some of them are used in research, while others have found a place in the entertainment industry. It's been a fascinating journey, hasn't it? From the ancient Greeks to Leonardo da Vinci, and from hand-launched models to computer-controlled drones, the evolution of ornithopters encapsulates the human spirit of innovation and our enduring fascination with the magic of flight. But as you can imagine, this journey hasn't been without its fair share of challenges. Up next, we'll delve into the technical hurdles and limitations faced in the development and operation of ornithopters. Stay tuned. Moving on, let's delve into the nitty-gritty and discuss some of the technical challenges and limitations faced in the development and operation of ornithopters. Firstly, I think it's important to note that bird flight is incredibly complex. Birds have evolved over millions of years to perfect their flight mechanics. They can adjust a wing shape, size, and even the angle of individual feathers in response to changing flight conditions. Mimicking this level of control and adaptability in a mechanical device is understandably a monumental task. One of the biggest challenges in creating ornithopters is achieving the flapping motion. It might look simple, but it's a complex interplay of forces. The wings need to generate enough lift to counteract gravity and enough thrust to overcome drag, all while consuming as little power as possible. And remember, the wings aren't just flapping up and down, they're also twisting. Designing a mechanical system that can perform these intricate movements reliably and efficiently is quite a feat. Then there's the issue of stability and control. In a traditional fixed-wing aircraft or helicopter, adjusting the throttle, ailerons, or rudder can easily change the speed, roll, or direction. But in an ornithopter, the wing is constantly in motion, making control a lot trickier. Also, let's not forget about the weight constraint. The heavier the ornithopter, the more power it needs to generate to stay aloft. So there's always a trade-off between the weight of the onboard equipment, like batteries or sensors, and the flight time and range of the ornithopter. Finally, there's the challenge of durability. The constant flapping motion places a lot of stress on the wings and the mechanical parts, which can lead to wear and tear over time. This means that the materials used in construction need to be both lightweight and strong, which can often be quite costly. In conclusion, while the concept of ornithopters is beautifully simple, an aircraft that flies like a bird, the reality is a complex balance of aerodynamics, material science, power management, and control systems. But despite these challenges, we've seen some amazing progress in the field of ornithopters, thanks to various technological innovations and breakthroughs. And on that note, stay tuned, because up next, we're going to discuss the different applications of ornithopters and their potential future uses. All right, we've discussed the mechanics, the history, and the challenges of ornithopters. But where are these bird mimicking machines used? Let's delve into the various applications of ornithopters in areas like surveillance, research, and even the entertainment industry. Starting with surveillance, the unique flight characteristics of ornithopters make them ideal for this purpose. Their ability to hover and fly slowly, combined with their bird-like appearance, makes them less noticeable, and therefore perfect for discrete operations. Miniaturized versions, often referred to as nano-ornithopters, can be used for indoor surveillance, while larger models can be employed for outdoor or military surveillance. Moving on to research, ornithopters provide scientists with a unique platform to study various aspects of flight mechanics and aerodynamics. They can be used to test theories about bird flight and to develop new technologies in fields like material science, control systems, and power management. In the entertainment industry, ornithopters bring a whole new dimension to drone technology. They can be used in filmmaking for aerial shots or as a part of live performances. Imagine a flock of lighted ornithopters soaring above a concert stage. Sounds pretty cool, right? But that's not all. The potential future uses of ornithopters are endless. With the advancement in technology, we can see ornithopters being used for tasks like crop monitoring, wildlife observation, and even search and rescue missions. They can also play a role in space exploration. NASA's Mars helicopter Ingenuity, though not an ornithopter, has shown that unconventional flight methods have a place in space exploration. Who knows? We might see ornithopters flapping around on other planets one day. In conclusion, while ornithopters may not be as widely recognized as conventional aircraft, they've carved out a niche for themselves in various industries. And with continued research and technological advancements, the sky is literally the limit for these bird-like machines. But before we wrap up, let's take a look at some of the technological breakthroughs that have made these advancements possible. Stay tuned. It's time to talk about the exciting part, the technological innovations and breakthroughs that have contributed to the improvement and efficiency of ornithopters. To begin with, material science has played a monumental role. With the advent of lightweight yet strong materials, such as carbon fiber composites and various aluminum alloys, the construction of ornithopters has seen significant evolution. These materials have made it possible to build more durable and efficient structures that can withstand the stresses of flapping flight. Next up is the realm of power technology. The development of more efficient and compact batteries has extended the flight time and range of ornithopters. Solar power technology also holds promise for future ornithopters, potentially allowing for virtually unlimited flight durations. Let's not forget the advancements in control systems. Modern ornithopters often incorporate complex computer control systems that allow for more precise and stable flight. These systems can adjust the flapping motion in real time to respond to changing flight conditions, much like a bird adjusts its wings. The field of aerodynamics has also contributed greatly. By studying the flight of birds and the physics of air movement, engineers have been able to design more efficient wing shapes and flapping mechanisms. The understanding of active twisting, where the wings twist during each flap, has also led to significant improvements in flight efficiency. Additionally, the development of microelectromechanical systems has led to the creation of microornithopters. These tiny devices, some of which are no larger than an insect, can be used for applications such as indoor surveillance or pollination of crops. Lastly, the evolution of 3D printing technology has had a significant impact. It enables rapid prototyping and testing of new designs, significantly speeding up the development process. In conclusion, the journey of ornithopters from ancient Greek dreams to modern technological marvels has been made possible by a series of key technological innovations. These breakthroughs have allowed us to create machines that can mimic the elegant and efficient flight of birds. And with continued research and technological advancements, who knows what the future holds for ornithopters? One thing is for sure, it's going to be an exciting journey, and I can't wait to see where it leads us.